All right, thanks for tuning in, everyone. Today we are working on Leetcode Kata. So the point of a kata is that it's an exercise that you do over and over and you basically have it memorized. So this can be used for a warm-up is the main idea that I'm going with. Recently wrote the 5 to 23 patterns to ace any coding interview, which is an enhancement over the 14 patterns article, which is a well-known interview prep resource. It's also an enhancement over the Blind 75 and Sean Prashad's patterns, which I've now contributed to. So it aggregates a bunch of these well-known resources and then builds even on top of that. It gives you a more narrow starting point, so it's easier for the beginner, and it gives you a more inclusive destination, so it has even more patterns than Sean Prashad's tool. Sean Prashad's tool has 22, and this has 23. There are 11 kind of like really important patterns. Even for juniors, I want them to know 7 of the 11. But for mid and higher, you definitely need to know 11 of these 23 patterns. You don't need to know all 23. That's overkill. That's for the completionists. So for the 11, I would like to create a kata regimen that basically has you go through either the majority / all of these. We're going to try and dive into that today and see like how much coverage I can get. In the worst case, you would need 11 practice problems to cover 11 patterns. In the worst case, I would like to try to avoid that. We might not be able to though. And then that brings another tension, which is like, if I have to do 11 problems, that's too much to do in like a 1 hour warm up, let's say. Let's say I just have a couple hours before my interview, and I'd like to have a protocol, a regimen that will get me ready to interview. And that protocol is not just like grinding problems. It needs to be more than that. There needs to be a component of like rest. There needs to be a component of like taking a deep breath and having some relaxation time. There needs to be a component of like grabbing some coffee, or like making sure that I'm not hungry, that I'm not, and also taking care of noise and physical distractions. So let's say that you have 2 hours before your interview, and I would like to absolute max out on the kata portion at 1.5 hours. I'd like to keep it under an hour, ideally. So what we may end up doing, I may end up suggesting a 2-stage kata, where it's like the day before you do some problems, and then right before you do just like 1, 2, or 3. And so that would be doable, but then you're sort of, not all 11 patterns are equally fresh on your mind, but that's also maybe okay because not all 11 patterns are equally used. All right, so that's the background for what we're doing today. I guess my chat is kind of not working. Let's see. Give this 5 seconds, maybe I can fix it. Otherwise, we might not have a chat today other than TikTok. The TikTok chat is working fine. Oh, click all the bicycles. Okay, maybe it'll work. Yeah, chat's not working. I do see, oh, thank you for the likes in TikTok. I do see the TikTok chat, but the YouTube and the Twitch, I don't know, they're giving me some problem right now. Okay, so 3 sum, I'm pretty sure I want 3 sum to be included. Right, so 3 sum should be part of the kata. You could do 2 sum, but it's too trivial, I think. So 3 sum is better. 3 sum is a medium, but you can still also write it out quite quickly. So I think it's pretty beneficial in that regard. I like LRU cache. I was thinking about including this one, but reviewing Sean Prashad's tool, it's not in here. So let's go back to the actual Leetcode site instead of Sean Prashad's tool. Let's look at Leetcode. So LRU cache on the solution, it says a ordered dictionary approach and then a hash map double linked list approach. But they have the same space and time complexity. In the ordered dictionary implementation is way more like straightforward to me. So I guess I could include this as a like a doubly linked list problem, but I don't even prefer the doubly linked list solution. So I don't think that's a good fit. So we might not have LRU cache in the kata. Okay, so I always like to sort by frequency. One of the virtues of LRU cache is that it is a top question. It's very frequently asked. How is it tagged? Yeah, it's tagged as a linked list, doubly linked list problem. But I would not solve it with a doubly linked list. Sorry. Let's look at our topics. Is ordered dictionary even in here? I don't think ordered dictionary is in the 11 patterns. So the 11 patterns are the 14 patterns minus 3 low value patterns. 3 low value ones are bit magic. So we need a sliding window problem, yeah. Bit magic and number theory and dynamic programming. Fast and slow pointers. All right, so here's how we're going to do this. I'm going to go to Leetcode and look for these patterns and then sort by frequency so that I'm picking the highest frequency ones. So let's look for 2 pointers. Cool, so we have 2 pointers and these are sorted by frequency. We already have 3, oh, we already have 3 some. Yeah, trapping rainwater is a good one, but it's a hard. I don't really want the katas to be hard. I'm happy with medium, and if I can't find a good medium, I'll do an easy. The idea is to go through them quickly. So, okay. Valid palindrome could be a good one. Lots of palindrome questions out there, aren't there? So, oh, this one has no solution. That's rough. Okay, so this is flagged as 2 pointers, but there's no solution. So how can you flag it as 2 pointers? This is also flagged as greedy and as a string manipulation problem. So this is a good candidate, I think. Let's bring up a list, notepad, so that we know which patterns we're covering by which problems. So 3 sum is for 2 pointers. Possibly yeah, LRU cache, I don't think we're going to use it, unfortunately, which is that's pretty unfortunate because I like that problem a lot. Possible valid palindrome for string manipulation and or greedy. See, that's a case where we're knocking out potentially 2 patterns with 1 problem. And that is something we'd like to do, and that way we can cut down, we can get to 11 patterns with less than 11 problems. So that's kind of a 2-for-1, so maybe that's a really good idea. Next permutation, count binary substrings. I'll look at these two, and then we'll move on to, I think these are still tagged under pointers. Oh, the stock one. How about stock? Best time to buy and sell stock. And so there's a 1 and a 2. Let's look at the 2. Well, the 2 is not super frequently asked. It's sitting at 63%. So let's look at the 1. So this is set under dynamic programming, but it's not a dynamic programming problem. This is a greedy algorithm. And it's also listed under arrays. Yeah, okay. So this could be possible greedy plus array, buy and sell stock. I'm terrible at Leetcode. Hey, me too. The point of this is to get better, but you don't have to be good to get better. It's arguably easier to get better when you're terrible to start with. So the cup's half full. Okay, so this is array and 2 pointers for next permutation. Yeah, I'm actually not super familiar with this problem. What is the frequency it's asked at? Let's see. Two pointers, string, and greedy. Yeah, dang. I think we need to go with val and palindrome, y'all. It's a 3-for. It's a 3-for. If we do a 2-pointer solution. Let me go to the discussion tab. So there's no, oh, there is a solution. Yeah, there's no official solution for this, but maybe one of the unofficial solutions, maybe one of the unofficial solutions uses 2 pointers. So here I'll go JavaScript. Oh, it reused my existing tab. That's no good. All right, so I'm going to copy this and click back, back, back. So we're here, and then in a new tab, I'll open this one so I can compare them both. All right, so this guy, nimble player, faster than 100% of JavaScript submissions. And this is the 2-pointer approach. Is this really faster than 100%? I'm going to try this out because it looks like it has a while within a while. Next permutation is a surprisingly simple solution that is not really difficult to come up with. Hey, read Wider Ryan. I have a question for you. It sounds like you're familiar with the problem. Would you recommend that as a good practice problem, or are you suggesting that it's like so easy that it's actually not a good practice problem? Let me know your thoughts. Not within, that's 2 separate. So this -1 is a while loop, and then within this while loop, it's calling -1. So that's why I'm saying that they are nested. Okay, so I'll try out this guy. Let's just try out this solution. Before I try it out, I want to try to understand it. So, yeah, we start with the left at 0. We start with the right on the far right. Okay, cool. So it's 2 pointers. And we're saying until the pointers meet, the left character, yeah, if the left character and the right character are not the same, return -1. What is the logic here? I think it's just checking that it is a palindrome. Oh, okay, or, because you're allowed to, yeah, in the prompt, you're allowed to delete at most one character. So that's why it's doing or, like either one of these could work. It actually is difficult to come up with the solution, which makes it a bad interview problem, IMO, but places like Facebook actually ask it in an interview. So that's kind of helpful. I'm not super interested in whether it's a good interview question. I'm interested in whether it's a good practice problem to help refresh the patterns in your mind. So if it's a really obscure pattern, I don't want that. But if it's one of the common patterns, that's what I'm looking for. Does that make sense? Okay, let's look through this quickly since we're talking about it. A permutation, I think having one practice problem that includes permutations is a good idea. Although I'm not saying this is the one necessarily, but I think that would be a good idea. What do you mean by patterns? Like the okay. Yeah. So what we're doing here is coming up with kata. Kata are drills that help you remember things, basically. It comes from anyway. It comes from martial arts, where you're remembering physical stances. Instead, we're remembering like mental stances. So 14 patterns to ace any coding interview. This is like a well-known interview prep document. I recently released 5 to 23 patterns that builds on top of that. It is an obscure pattern. Okay, thank you for that. Okay, so we'll skip it over then. All right, thank you for that. So anyway, these kata, we are trying to find a few practice problems that can help us remember. There's 11 of these that are like very high value. So I would like to get ideally like 3 to 5. If I could do 3 to 5 questions to cover 11 patterns, that would be ideal for me. In the worst case, you might need 11 problems to cover 11 patterns, but I don't think that's ideal. Okay, so this solution to the valid palindromes looks good to me. So let's try it. Yeah, and so this is just shifting, I think. Got it. Yeah, so this is allowing an off by 1, and then in this case, yeah, so that's what they mean by -1. They're talking about like dropping a character. I take like an hour to do an easy. Yeah, but if you drill it, you won't. That's the thing, it's just drilling. So learning a problem is hard, but once you understand the solution, drilling it, you'll go from 60 minutes to 10 minutes if you just practice that thing like 30 times. And you can't do that in one day, right? You would need to do that the way memory works. You would need to spread that over like a few days. All right, so let's try to implement this solution. I'm not just going to copy it, but I think I understand it, so I'm going to try to rewrite it. All right, so we have a valid palindrome. I'm going to say to do try ES6. We might get higher performance or memory parameters just by rewriting it to ES6, but we'll do it this way for now. So we need a helper. The helper is valid palindrome after removing character. Okay, so here It looks like the first part lowers the values for comparison. Depending on what you mean by that, you would be correct. Yeah, you might want to work on wording that better though. But that's, yeah, you're potentially correct. So we'll eventually return true if we make it that far. We're going to have a while loop. This is like ordinary palindrome check. We're going to say let left equal 0, let right equal s dot length minus 1. 2 pointers approach while left is less than right. We'll do the things, and then we will increment left and decrement right. The second part just does part 1 for characters. No, the second part is doing the same logic as the first part. However, if there is a mismatch, it will immediately return false. Where in the first part, if there's a mismatch, you get a second chance because you can omit one character. So let's do that now, actually. So if there's a mismatch, and we know there's a mismatch because s left is not equal to s right. That means there's a mismatch. You get 1 second chance. So then we're going to return var y, because Leetcode does that by default. I spoke to that earlier. I said to do try ES6, but we're going to do it this way. And then we'll see if the ES6 is faster. Yeah, this is JavaScript. Yes, but doesn't the false Boolean make the function repeat itself? No, it does not. The false Boolean does not make the function repeat itself. So we're going to do valid palindrome after removing one character. So I need to rewrite this. Let's see. I think I want to slice S. Is that correct? Maybe I don't need to slice it. Maybe I can just pass my indices. So which one do we omit? We can try omitting a left, and we can try omitting a right. All right, so in this case, return true if we make it that far. We have left and right coming in. And you do not get a second chance in this case. So we just return false. You are just learning. I mean, I haven't done this specific problem before, but the main point of this is not learning. The main point of this is picking kata. So kata are just drills. And so there's like a bunch of patterns in algorithm data structures and algorithm interviews. There's a bunch of patterns that are really useful, and it's hard to remember them all. So one thing that we can do is we can come up with kata or drills, and basically that will help us memorize the important patterns. And it will also be a good warm-up before our interview. And again, if you're on YouTube or Twitch, and if you're trying to use the chat, I apologize. My chat is not working today. Okay, great. So does this work? Is there any, let me step through it, and then we'll run it. So left and right. In the happy path, this never hits because it's a perfect palindrome, so this never hits. We return true. What if this does hit? So I have A, B, C, A. ABCA. This will hit on the C. Then I'll check both of these. ABCA. In this case, right here, I'm expecting it's true because it will bypass the C and it will treat it equivalent to ABA. So let's see if this works. Oh, that pun was not intended. Let's see if this works. Good stuff. Haven't heard about Kata. K-A-T-A. K-A-T-A. Did you learn solidity yet? No, I did not. Cool. So yeah, I get my left and my right. Left is not less than right. They're actually equal in this case because we're bypassing the C, and so we're checking B only. So if they're not equal to each other, well, we're checking B only, so they are equal to each other. So we increment left, decrement right, break the loop, return true, pushes it up to here, return true. Yeah. Okay, so let's run it. That was accepted. Let's submit. And it was accepted. Okay, great. So, yeah, I was kind of sus about the speed claim here. Faster than 100% of JavaScript online submissions. Well, he's saying that his is faster somehow. There's a lot of variation in these submissions. I can just submit it like 3 times and I'll get like pretty different metrics sometimes. Okay, in this case, not so much, huh? Yeah, so I'm not sure why this guy is like claiming such good metrics. Oh, well, so does moving this in actually change the performance that much? It made it slower, right? Yeah, so moving the function to the within the scope actually made it slower. All right, let's try ES6. So here we're going to say const valid palindrome equals S. And that was faster. Hey, it's Code Wars. It's Leetcode. Yeah, it is a martial arts term. Thank you. So yeah, so ES6 is less memory and faster runtime. So, oh wow, that was much faster, wasn't it? So use ES6, boys and girls. There's like so much variation. That's kind of ridiculous. Anyway, this one was in the top like 2% of submissions. That's pretty cool. All right, so I'm a fan of this approach. It's definitely 2 pointers in string. You could call it greedy, I guess. Yeah, 2-pointer string greedy. Okay, it's a good problem. I'm a fan of this problem. And I'm also using the LeetHub extension. So let me check my GitHub. My GitHub should have been updated now. So let's see. Valid palindrome 2 updated a minute ago. Oh, it's telling us we're in the. I'm gonna need to do that again because it's not giving me credit for that. That like top 2% or whatever. All right, I'll take top 5. I'll take top 5. So I think this is a great kata. This is like a nice short problem. We break out a helper method. We have nested loops, and yet it is still not n squared. It is O of n. because the loop is not calling the other loop at every time. It's only possibly calling it at one point in time only. It's like a handoff. It's not like a loop calling a loop over and over. So it's just O(n), and the memory is constant. So this is like a really efficient solution. Cool. So we have our kata here. So this is string manipulation. I'll just say string, greedy, and 2 pointers. Threesome is also 2 pointers. Can you please, in a 5-word, explain how or is this site helping you? This site helps you learn and practice algorithm problems. That's it. That's all it does. So they help with a special form of interview, which is called a data structures and algorithm interview. Okay, so it is also an array problem and a sorting problem. Yeah, okay. All right, cool. So I get to keep it. I was gonna be like sad if I had to cut threesome because val and palindrome like covers all the scenarios. To be a better backend dev. No. Controversial opinion here. Leetcode is not gonna make you a better developer. It doesn't make you better as a developer at all. It doesn't help backend developers. It doesn't help front-end developers. It doesn't help developers program at all, in my opinion. It just helps you pass interviews. I disagree that Leetcode is a good way to make you a better developer. I disagree with that. Okay. Cool. So we've got 2 problems, and that covers 1, 2, 3, 4, 5. We've got 2 problems, and it covers 5 patterns already. I'm very happy about that. So buy and sell stock, it is just redundant with these top 2. So I'm going to cut that one. Good problem, but we're not going to buy and sell stock. Just not to freak out on interview. Yeah, I guess. I mean, it's not really about freaking out. It's about performing. But I guess it'll help you not freak out too. Thing is, you don't have to freak out to fail. Like, you could be. Trust me. Like, it's not the case that I only fail interviews when I freak out. Like, you can totally not freak out, and you just don't know the answer. It happens. Contains duplicate is a good one, but it might not have any new patterns for us. Excuse me. Count binary substrings. Let's see, related topics. 2 pointers in string. Nope, I don't think so. Valid palindrome. Cool, we're done with that. All right, so what is the next pattern? Let's list out our patterns. So the top 11 patterns, 1, 2, 3, 4, 5, 6, 7, whoa. Thank you for your answers and for my practice in English. You're very welcome. You're doing quite well. How long have you been speaking English? Okay, so the top 11 patterns, let's just name them for, yeah, we want sliding window. Two pointers. This is a variation of two pointers plus fast and slow pointers. Merge intervals, that's one that we have not done. Okay, I guess fast and slow pointers is its own. It's really similar to two pointers, but we'll split it out. It technically is a subset of two pointers. I am not speaking English at all because in Israel I use just Hebrew and Russian. Oh, very cool. Okay, merge intervals. Next one is cyclic sort. Let's read through this. I always forget the difference between cyclic sort and sort it all. Hello, Sam. Oh, they even suggest some problems. So here is intervals intersection. Let's see. Fast and slow pointers. Cycle and circular array. Ooh, maybe we do have a hard. That would be crazy. Longest substring with k distinct characters. Yeah, it could be either of these. We'll look at which one of those is more frequent. So cyclic sort, I'm wondering, like, what is the difference between this and just like a normal sort? I don't get it. like a bubble sort. Right? Isn't that just bubble sort? Sometimes referred to as sinking sort. Bubble sort versus cyclic sort. Ooh, data structures I see. Yep. Okay, is the idea that it's because it's displacing cycle sort like displaces an element where bubble sort doesn't? That's all I can gather is that cycle sort is using a displacement. Let's see if that's what they mean over here. 2 is not as its correct place. Let's swap it with the correct index. There's no displacement here. And this, what the 14 patterns is calling a cyclic sort, it doesn't have displacement. It just looks like a bubble sort to me. Cool. Let's look at find the missing number. Let's look at this problem, and maybe that will clarify things. I'm just going to jump to the solution. So it says approach number 1, sorting. Right, so we all agree that it's like sorting. Is it a bubble sort? Is it a cyclic sort? Can we just say sorting? Bit manipulation, get out of here. Gauss formula, get out of here. Those are absurd. That's absurd. Hash set would be cool. O in time complexity, O in space complexity. So the sorting solution is not even optimal here. So this would be a rather poor kata, because if you're like, oh, this is the sorting problem, and then you sort it, and you end up with a non-optimal solution. So really, hash set is the optimal solution here. Whoa, look how tiny that is. I mean, it's an easy problem to solve, right? So, okay. Yeah, this is a terrible approach. So trying to sort and then looping through the sort is like a terrible approach here. You definitely want to use the hash set. Yeah, that solution's in Python. Okay, so let's look at the sort implementation just to see. So even though you don't want to sort here, but let's, whatever. They just call sort. They just call the built-in sort. Oh, I'm so pissed about this. Cyclic sort, this pattern is dirt. This is a dirty pattern. Dirty pattern. I'm going to check the blind 75 or Geeks for Geeks. So I don't believe in the term cyclic sort there. It's, you need to know when to use sort, that's true. But there's nothing special about this word cyclic. Okay, great. So let's go back to the patterns. In place reversal of linked list. BFS and DFS, you can often use the same program or the same problem and just write out the BFS and write out the DFS. I guess it wouldn't hurt to have two problems there though. Binary tree level order traversal. Yeah. That's going to be good because it helps us remember what is level order traversal. BFS, DFS. Sum of path, numbers, all paths for a sum. Honestly, both of those are great. Sum of path is what we're often doing. Here, let's search. Sum root to leaf. So it'd be like 13, 18, right? Oh no, did I get that wrong? Sum root to leaf numbers. I think this is a different problem. Sum of path numbers. Oh, it's like behind a paywall. Lame. All right, so look at that. He does 12 plus 134 plus 135. Okay, so he's adding up all of the leaves. It's not just one. Okay. So I guess that is the problem. Coding, not quite coding. There's been some coding, but we're trying to develop Kata, which is like drills that help you remember optimal algorithms. All right, so this would be 12 plus 13, so we get 25. Yeah, okay. And what is this other all paths for a sum? Nine, 20, 22, 13, 17, 22. So they both add to 22. I think this is actually a more interesting application. Because in the other case, it's just like get all of the leave paths. You could actually do that with BFS or DFS. One might be more optimal, but it's not really it's not really like idiomatic of like what that algorithm is for. This one I think is. Because you can see you're taking a narrow route. Like I don't want to check all the routes, I just want this route and this path. And that's what DFS does. It goes down a path before it checks a whole level. So A star, uh-oh, no, by someone scary in the chat. So I'm gonna pick this one for the next kata. So this is DFS. Okay, and then I'm putting the link. Okay, so we know this includes DFS, but what else does it include? Oh, I look at the tags for that. Related topics. Oh, it has backtracking. And it's a binary tree. Hells yeah, dude. Hells yeah. Great. This is a great problem. So this is binary tree. DFS. And backtracking. I'm loving this. Those are all unique patterns compared to our other problems. So now we've got 8. We've got 8 patterns covered with 3 problems. That's so great. Okay, so we got BFS and DFS. What is the next pattern? 2 heaps. I don't actually believe in 2 heaps. Sorry. Subsets. 2 heaps, subsets, modified binary search. I'll just say binary search. Top K elements, that's going to be a good one. K-way merge. I don't know. I can't remember if I've like used that ever. And topological sort, which we do need that one. All right, so I want to eliminate 2 heaps. So this would be 8, 9, 10, 11, 12, 13, 14. So that would be all of the 14 patterns, but we're only interested in the 11 patterns. So get rid of 2 heaps. I don't know which you ought to get rid of. So let's look at the Geeks for Geeks. top 10 algorithm interview questions. Search an element in a sorted or rotated array is a really good idea, especially with matrices. Yeah, matrix. So I want a rotated matrix problem. Oh, is that the name of the problem? Let's see. Search in rotated sorted array is the name of the problem. Wow, that's a good name. I guess I guess I solved this one back in the day. Okay. So let's look at the tags on this. Binary search. Binary search for optimal solution. You know, I don't think I did a binary search. So yeah, I don't know if I had a very good answer. Get target from array. Let's look through my code and try and figure out what I was doing. Get target from array. Well, this is just an array. This is not a matrix. I want something that rotates a matrix. So I just did a recursive approach here. Okay, so I'm getting the subarray. Yeah, I guess I'm doing a binary search here. It's just kind of an ugly one. So does there's an integer array num sorted in ascending order with distinct values. Okay, so it comes sorted. It comes sorted. So this is, I mean, my solution's not great, but this is a great problem for binary search. The only issue I have with it is that it's really only giving us one pattern for a problem here. So I'll, let's see, binary search. So we have a good binary search problem, but from a Kata perspective, it's not super efficient because it's like, it's one for one, right? Topological sort. BFS, DFS, and topological sort are all for graphs. Yeah. So yeah, I guess I'll group these together. So we still have top 9 patterns. Oh, we're looking for top 11 patterns, and we now have top 10. Okay, so we got it to the I guess we overgrouped. Katas are good. Python is ERK. Personal preference C#. Is Python difficult like English or French to learn? Python is far easier than English. I can't speak to French. I don't know. I don't know French. All right, so I grouped graphs, but let's split them back out now. So here's the problem: is if I group them, I'm at 10, and if I split them, I'm at 12, and I'm trying to get the top 11 patterns. So that's not very good. What's for katas? Katas are drills, basically. They are practices that you do over and over so that you can learn the pattern as if it's second nature. You don't even need to think about it. You just see the problem and you just immediately know because you've done the problem so many times. Yeah, K-way merge uses a heap, and I don't really believe. Yeah, I don't really believe in heaps. Heaps are not frequently asked questions. So we'll get rid of K-way merge. Okay, and now if I split it, I have, yeah. So these are the top 11 patterns. Okay, so we have covered. Yeah, so I need a sliding window problem. Let's look at these two. Maximum sub array. Let's not go for the easy here. Long substring k distinct characters. See the related topics. Hash table, string, sliding window. Yeah, a lot of these sliding windows are just going to be string manipulation problems. Let's look at the blind 75. Array, he has 2 sum. I already got 3 sum, so we're good there. Let's see. So 3, yeah, we got array covered. Binary, this is like bit magic, so we're skipping that. Dynamic programming, we're skipping that. Graph. Yeah, so we need some of these graphs. Alien dictionary, that's a good one. I've definitely seen the alien dictionary problem multiple times in my interviews. Oh, this is considered a hard? Is it because it uses a tree? Breadth first search. Depth first search. Just BFS or DFS. Okay, so is DFS actually better? Time complexity is O of C. Space complexity is constant or not constant. O of C. Yeah, so the time and space complexity is equivalent between them. Yeah, so there's a bunch of stuff going on here. Wow. Okay, so maybe I should grab this problem. For me, it's going to be a breadth first search problem. And it's interesting because it uses strings, but you navigate it like a graph. Let me read the problem statement. There is a new alien language that uses the English alphabet. However, the order among the letters is unknown to you. You are given a list of strings from the alien languages dictionary where the strings and words are sorted lexicographically by the rules of the new language. Thanks. Something got dropped off, Tina. A string S is lexicographically smaller than a string T if the first if at the first letter where they differ, the letter in S comes before the letter in T. Right. That's just like, yeah, okay. That's just how lexicographic sorting works. So they want us to output, yeah, they want us to output the, they want us to output the alphabet. There's a new alien language that uses the English alphabet. Clearly, it's an array problem and a string problem. Where does the topological sort come in? That's what I'm interested to see. Extracting dependency rules from the input. For example, A must be before C, X must be before D, or E must be before B. Topologically sorting just means having sorted by dependencies, right? Topological sorting. I'm not, yeah, okay. I'm not actually seeing where any topological sort is done. It just says, it's like it says the word. Remember that in ordinary English dictionary, all the words starting with A are at the start, followed by all the ones with B, C, D. Okay. Removing the duplicates, we get W, C, K, J. Cool. We know the relative order of 4 letters in the alien dictionary. Right, so that's why I'm kind of surprised they don't use a tree here. So they could have a tree, or a trie, with W, C, K, and J. Because then you need to inspect within the W's, within the C's, within the K's, within the J's. All the way down the word, potentially, in the worst case. Ah, this is where the topology comes in. The problem here, though, is that hi, amazing analogy. Can you give me some pointers as a newbie how to start? Yeah, if you're trying to learn how to code, check out Code Academy. What we're doing right here is like pretty advanced. This is like not noob stuff. So yeah, if you mean how to start doing algorithms, we can talk about that, but you want to be able to program before you dive into algorithms. If you're trying to learn to program, check out Code Academy. Noob in React.js, experienced in SQL. Cool. Yeah, check out Code Academy front end path. So this adjacency list, how is it implemented? Is it implemented as a, let's go look at the code. Is this implemented as a hash map or as a array? Or even an ordered, or even like an ordered dictionary? Okay, so, wow, this is like, the code here is super clean, isn't it? Okay. Sheesh. If not all letters are in output, that means that there was a cycle and so no valid ordering return. Yeah. Create data structures and the in degree of each unique letter to 0. So it's a default dictionary. It's just it's a set. What? It's a set. Okay. Why would you not just use a dictionary? Why would you use a set? Oh well, works for me. Of C add D. So this could be, in JavaScript, this could just be a hash map. I guess there's some advantage to using a set. I'm not super clear what the advantage is, but I think it works just as well with a hash map. Print hello world, pro move. So yeah, this I'm a little, oh, thank you. This I'm a little confused about. Adjacency list C add. I'm starting to think this is not a set, but it's a dictionary of sets. Yeah, so I think this is a dictionary of sets. Yep. That's what they did. Okay, cool. I was having trouble understanding what was going on. So this is not creating a set. This is creating a dictionary of sets. Where'd we go? Whoop. I'm getting a phone call from Vienna. What? We're not expecting a phone call from Vienna. Okay. I don't know what's going on with that. Oh, and the guy coming out got canceled. Pat some too. We don't want this one. Where did my alien problem go? Did I close it? Sorry, y'all. I think I'm done. Alien dictionary. No, this is the wrong one. This is the wrong one. The Alien Dictionary hard is what we're looking for. Yep. Okay, so here, if we look at the solution, this is the solution. The solution, right here on line 7, this adjacency list is not a set. It is a dictionary of sets. And then in degree is a dictionary of counters. Or it's like a collection of counters. Cool. So in JavaScript, those would be hash maps. All right. So I like this problem. Okay, and I've got it through, and I like that it uses a set because that's something I don't think we've used elsewhere. If not all letters are in output, that means there was a cycle, and so no valid ordering. Repeatedly pick off nodes with an in degree of 0. Why is it called an in degree? for first word, second word, in zip words, words one. So that's like taking two lists and like creating a new list with the first and second index. Bam, bam. So this is just first word, second word. C and D is first word, second word. Yeah, in zip, first word, second word. So for each pair of words, this is actually 2 pointers, but neither one of them is slower. It's like fast and fast pointer. If the words are not the same. So would they just have like duplicate words, I guess? Check that the second word isn't a prefix of the first word. What? Is this a Python thing? If C is not equal to D, if C is not equal to D, yeah, I feel like this else indentation is off, isn't it? Okay, so I think I need to come back and solve this problem in JavaScript to get a better picture of what's going on. But anyway, I'm happy with the overall approach. Where's the topological thing? We need to repeatedly pick off nodes with an in degree of 0. So it's trying to understand this in degree. If D not in the adjacency list of C, yeah, so in degree is like the number of adjacency lists that it's in. So pick off the nodes with an in degree of 0 means pick off the nodes that are not in any adjacency lists. So yeah, so Q output, yeah, so it's getting all of the nodes that are not in any adjacency list and it's appending them to the output. For D and adjacency list of C, C equals Q dot pop left. Yeah, so these would be, let's see. So it has no dependency. I put in the output, and then I look at its adjacency list. And then yeah. So this is for each letter in the adjacency list. I'm removing the in degree because I'm inspecting it right now. If it's 0 right now, then it was only dependent on things that are already in the queue. So it has no further dependency, so we'll put that on the output. Otherwise, to the back of the queue you go. And keep doing that until the queue is completed. I really like this problem. And the time complexity ends up being constant, which is wild. Yeah, the adjacency list pattern here is pretty interesting. That should almost be like its own pattern. Let's see if it has a tag for that. There's no tag for that. It's like topological sort and adjacency list are being used as the same thing. So yeah, that's okay. Topological sort / adjacency list. Cool. So I'll use this problem. This is a hard, but that's okay. I'm okay with it. If we look at the code, even though it's a hard, the code ends up being pretty concise, which makes it a decent kata. It's under 50 lines. Yeah, I think that's even a decent rule of thumb. Let's try to keep kata under 50 lines. What is the frequency of this question, by the way? I think this problem has a low frequency. Oh, it's over 75. Yeah, so maybe this is like too difficult. Oh, it's a common pattern. Good to know. Yep, I agree with that. My hesitation is that this is a hard problem, and I'm averse to having too many hard problems in the kata. But I guess if we can keep it to 1 and 5, I'm good. Yeah. Yeah. Just kind of jotting myself some notes. I'm going to obviously write this up into an article and share that out. Yeah. So this has topological. Here we got BFS. What are these intervals? Merge intervals, non-overlapping intervals. These are both medium. Let's look at the frequency. So here, yeah, merge intervals is, yeah, over 99%. That's really good. Non-overlapping intervals is way down the frequency, so we're not going to do that. We're going to do merge intervals. Just says array and sorting. Array and sorting. And this is a BFS because we're using a queue. Let's go check on that. Reverse adjacency list. Wow. Yeah, so visit calls visit. Yeah, visit calls visit. So this is a DFS. Recursion. Right, anytime you use DFS, you're using recursion. So this top one is a BFS because we're using a queue. Yeah, great. So we've got these three knocked out. We've got this one done. Merge intervals. Intervals intersection. Oh, we've got this one done. So merge intervals. Sliding windows not in the blind 75. Would you look at that? Wow. All right, maximum subarray of longest substring with k distinct characters. There's subarray sum. Longest substring without repeating characters. That's a good one. Minimum window substring is a hard, yeah, and it's not super frequently asked. What about this one? Yeah, this is over 90. Okay, so this is sliding window. It's sliding window, not a 2-pointers. I guess they're, so it's still 2-pointers, but I guess it's like a special kind of 2-pointers. Let me make a note. So notepad is these really go into one group. 2-pointers. Learning pointers in my course right now, it can get really confusing sometimes. Any tips? Practice, 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 practice. So with 2-pointers, I think there's like, really there's like 3 kind of like subgroups of this. One is the shrinking window, where you start on the far left and the far right, and they keep shrinking until they flip, until right goes shorter than left. And then you terminate the loop. So that's like a shrinking window. Then there's like a sliding window where they start on the same side and they kind of move to the right, and you can have both pointers move. You can have one pointer. It can grow and shrink as you move along. But sort of in the base case, you could think of like a width of 3, just a fixed width of 3, and they both move. So there's the shrinking window, and then there's the fixed width of 3. And then you realize quickly that you can combine them. So the fixed width of 3 can actually grow and shrink as it moves along, and it's more like a slug or a caterpillar that's like inching its way along the array. And then there's fast and slow pointers, where one is like a multiple of the other. It's like going out ahead. So we've done array, we've done graph, we've done interval, we've done tree, we've done string. So it's these two, linked list and matrix, we still need to do. Oh, that sounds complicated. Yeah, algorithms are complicated. Algorithms are complicated. So I need a good matrix problem. But then I also need subsets. And top k elements. Search rotated array. Let's see, the top 7. 5, 7, 11, right? So really, I need to prioritize linked lists. So what's a good linked list problem? All right. Reverse a linked list. Boring. Detect a cycle. Okay, maybe. So let's just search linked lists and go for high frequency. Merge k sorted linked lists. Ooh. Yep, so it's recommended there. Merge 2 sorted linked lists. Yeah, I like these. Yeah, so here's like the bit, and they're both, let's see, it's actually not as frequently asked. Look at that. So I'll do this one, even though it's harder. Divide and conquer. Da 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 da. Uses a priority queue. Boo, priority queue sucks in JavaScript. I'm actually not sure why this is called divide and conquer. It's like, I guess it's like a reverse binary. It's like a reverse binary tree. I think it's pretty straightforward. So yeah, I like this approach. I'm not. I realize that divide and conquer is like not super frequently like asked, but the overhead for the overhead for it is small. It's right here. So you merge two lists is most of the problem, which is its own problem, and then we just apply sort of like a reverse. It's an interesting thing to do. It's an interesting kata. It's a reverse binary. It's like a reverse binary tree. So instead of splitting, 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 you're merging, merging, merging. So I think it's a cool thing to keep in mind. It gives you a little extra practice. You're really getting like two additional concepts here, like 2 or 3 additional concepts for not much lines of code. So I'm a fan. So there's 5 like possible approaches, but I would go with the merge, divide, and conquer approach. And you could merge one by one as well, but it's going to be a lot slower, right? OKN instead of ON log K, yeah. All right, cool, so we'll include this one. It's hard to figure out, and this is actually one of the reasons that I've heard that DP programming questions are not asked in interview very often, because this is super hard. It would be super hard to figure that out. Maybe not, I don't know. Maybe not. You're given an array of linked lists. Each is sorting in ascended order. And you just go, okay, I can just merge them one at a time. It seems like sort of the obvious thing to do, right? And then a more creative thing would be we could pair them off and do this reverse binary thing. You could potentially think of that in an interview setting. Yeah. Thinking of the implementation would be a lot harder though. And I can avoid the heaps, which is a big deal to me. I want to avoid those heaps. And I don't lose out on the optimal solution by avoiding the heaps. In fact, the reverse divide and conquer is in log K01. In log K. It's just as fast and it's better for space complexity. So yeah, I like that about this. Cool. So there's several things I like about this problem, even though it's a hard. Okay. Yeah. So let's add that on there. This is linked lists, divide and conquer. And merge sort. Is it a merge sort? What website is this? Also, is this for at-home learning? This is Leetcode, and I don't really recommend it for learning how to code. No, this is for more like interview preparation for specific companies. If you just want to learn how to code, check out Code Academy or Free Code Camp. I guess that is a merge sort. It's just like really unimpressive. Let me look up merge sort. I feel like a lot of these things are like so much less impressive once you do them. Sort an array. JavaScript merge sort. Here we go. So merge sort numbers from 0 to length -1. And what if both sides are 0? We just return. Return void, and so then it just wouldn't sort nums. Which is okay, because it would be a single element. Yep. So merge sort cuts it in half. It sorts left, sorts right, and then it merges. It merges those halves. So yeah, it looks like the same idea where it's like this kind of like reverse binary thing. So you're able to get that log in. Yeah, I guess that's the thing to know about merge sort is you can get log n. You just cut it in half. You're recursively cutting it half all the way down. And then what about, yeah, eventually you terminate the recursion because you're getting to the single element at that point. How long did it take you to learn to code? It took me about a year. Cool. So this is, yeah, this is a, it says merge two lists, but it is merge, it's like a merge sort two lists, merge sort of two lists. Cool. So yeah, it's when it uses the tag merge sort there, it's no lie. So let's include it. Linked list, divide and conquer, merge sort. Linked list, divide and conquer. Yeah, and we're going to skip that heap priority queue because I don't want to use the priority queue solution. Okay, so now we have gotten graphs right? I got graphs, yeah. Alien dictionary. So we got graphs, got linked lists, searching and sorting, definitely did that. Let's see, binary tree has search. Merge intervals has sort. There's like sort is used in like 3 of these actually. So sort is well taken care of. Tree algorithms, BFS, DFS. Got BFS, DFS. And string and array manipulation, got those. Okay, so the 5 patterns are covered. This is not really efficient, right? So this is 6 kata to take care of 5 patterns. Okay, so we have 6 kata at this point, which is kind of good, but it's 6 kata to take care of 5 patterns, which is not good. Do we at least get to the 7 now? So what are the 7? Okay, so let's call this the 6 kata. And then the 5 patterns solved by 6 kata. And then what about the 7 patterns? So here are the 7 patterns. The only one I see missing is matrix. So intervals is not included in the top 5 patterns. So we can do top 5 patterns. So let's call this the 6 kata. Let's see if we can have a shorter kata that takes care of the top 5 patterns. Graphs, we are using Alien Dictionary for graphs. Then we get sorting is taken care of, and not tree, string and array manipulation is taken care of. So Alien gets this one, and this one, and this one. So we need 3 linked lists and tree algorithms. I feel like we should be able to find a problem that does linked lists and tree algorithms at the same time. So I'm going to do Alien Dictionary, and let's try to find one that does linked lists and tree algorithms at the same time. That shouldn't be hard. Oh no, tree algorithms is taken care of. Array string graph. So it's the sorting, it's linked list and sorting and searching. So there is topological sort. I want the searching though. Love me some binary trees, for sure, for sure. Path sum 2 has binary search, and it also has tree algorithm. I'm gonna look through some more linked list problem. So what is my issue with? So we currently have a linked list problem. We have merge k-sorted lists. What is my problem with this What is my problem with this problem? My problem with this problem is that I want to be able to do 2 kata that takes care of the top 5 patterns. So Alien Dictionary takes care of a lot. It takes care of graph, string and array, tree, but it doesn't take care of these 2. You could argue, if you want to argue that topological sort is, that's a kind of sort, okay, fine. Yeah, kind of. But topological sort is like a fundamentally different kind of sort. It's almost better categorized as a tree algorithm, because it's like sort by dependency on other nodes. So I'm going to say that it doesn't feel like good enough coverage of normal sorting, which would be like bubble sort, merge sort. So merge sort is like normal sorting, except it's like really fast because you do this log n thing. Let me double check. I think merge sort speed. Yeah, it's in log n. Why is it in log n instead of just log n? Problem for another day, I think. You're cutting it in half. Half, 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 half. So I'm thinking that's like a binary search, which is like log n. I don't know. I have to stew on that some more. Yeah, I know you're right. Sorting cannot be faster than n log n. Okay, but why? Why? Let's not just like, this shouldn't be a trivia game, right? Unfortunately, it often is. Leetcode often just turns into a trivia game. Yeah, so where does the additional n come from? That's my question. We know that binary. How fast is binary search? Is binary search also n log n? Am I just like remembering things wrong? No, binary search is log n, O of log n. And so with the merge sort, we are cutting it in half and merging it. I guess it's the merge operation that takes the n. So cutting it in half just takes log of n. Cutting in half, you can do that all day. Log n, log n, log n. It's merging it back together. Is that right? Let me know your thoughts. I think that could be right, that it's the merging it back together that takes the O of n. Anyway, that's how I'm thinking about it currently. Okay, yeah, if I can get sorting and searching and linked lists in a single problem, I would like that more, because currently merge k-sorted lists takes care of linked lists. Well, it does, doesn't it? It takes care of linked lists, and it also takes care of merge sort. So maybe that's exactly what I want. if we sort the intervals by their start value, then each set of intervals that can be merged will appear as a contiguous run in the sorted list. You okay?
Yes.
So this is what they mean by, this is what tech lead who created the blind 75, this is what he's referring to as intervals. I think this intervals concept is like basically contained within within the window problems. You all right?
I touched the most disgusting thing of my entire life.
What?
There was a paper towel at the bottom of the pot for the plant so that that water would soak it up. And I went to pull it out and it was just all like goop and mush.
Ew. I guess this is okay. Merge K sorted lists. Is there merge K unsorted lists? Oh, they added JavaScript. Look at that. Yeah, I kind of want to merge K unsorted lists. I just want to make the person like sort them, you know? Because the thing is like this merge sort, um, it's like not a normal sort. I mean, I guess there is a component where you have to sort it right there. You have to sort it numerically. So I guess I'm overthinking this, right? If these merge sorts, if it's a numeric merge k-sorted list, and if it's numeric, you're going to have to do an actual sort, I think. Let's see. Yeah, see, we're not actually calling sort in that case. But you're definitely sorting them. For unsorted lists, the conquer logic would need to sort it. Yeah, that's right, and that's kind of my point. What's up, Adam? Yeah, I would feel a little better about the problem as a study tool if you made the developer actually sort your list. So it's like this is sorting technically. It's just not like a normal sort. But maybe I'm overthinking it. Or use another merge sort for sorting each list. Yeah. You could do that, couldn't you? Yeah, so if they were unsorted, unsorted, it would take nk log k. And merging them one by one would be faster in that case. That's funny. NK. I guess that's the reason why they have to be sorted to begin with. Because if they were unsorted to begin with, it'd be just as fast to merge them one by one. How funny. Well, it is a highly asked question, so I think that gives us enough reason to keep it. All right, I think we finally broke the tie. I was over here debating. So linked lists and sorting are covered. Let's see. Yeah, we'll count merge sort. We'll count it. I'm not going to count topological sort, but we will count merge sort. All right, so with the 2 kata, Alien Dictionary merge K sorted lists. And we can cover the top 5 patterns. Graphs, linked lists. Kata is like a drill. You practice it over and over. The term has its origin in martial arts. You will just try this drill over and over, and then the movements become second nature to you. You don't even have to think about it. So you can use like your normal muscle memory. And for our purposes, we want to learn these patterns, programming patterns, as if they're muscle memory. So the interview comes, and we just know exactly what to do without really thinking about it. All right, so the top 5 patterns are solved by 2 kata. Now, given that we have 2 kata, what about the 7 patterns? We don't cover the matrix, basically. So I have merge K lists. graph, array, linked list. Okay, so interval. We need to do interval. And we need to do matrix. Is there any way I can do interval and matrix at the same time? Let's go to Leetcode. Matrix questions are not actually frequently asked. That's interesting. I feel like I have had a bunch of matrix questions. Maybe that's just weird for me. Number of islands. Yeah, the island problem is very common, right? Let's go back to the blind 75. So here, what is the matrix they recommend? He recommends spiral matrix, actually. So we look for matrix. Can we also look for interval? Yeah, nothing says interval, right? Okay. Set. Set matrix zeros, he recommends. I don't think I can recommend this problem. It's not frequently asked. Yeah. The island problem is the best one to ask in terms of frequency. I'll go down as far as spiral matrix. Really, I shouldn't. I'll look at this one because it's a hard. It uses a tree. Dang. Tree is not a common structure, actually. Or a trie. Array, string, backtracking, matrix. So this is a cool pattern, but this is definitely an advanced pattern. Okay, backtracking, let's try. I'll make a note of it just for like more advanced advanced kata. This is word search 2. But really, I don't want to recommend that one. So I guess water, the islands problem is the main one to recommend. Number of islands, yeah. This is a pretty common problem, I think. Well, actually, it was measured, so it definitely is. So do I recommend we do the BFS or DFS way? Let's see. OMN, space and time. OMN, space and time. DFS. So BFS is actually more efficient here. The time complexity is the same, but the space complexity yeah, this is a good one. Number of islands, okay. So matrix should be number of islands. So there's the 2 kata, so now we have matrix and interval. So let's do merge intervals. Yeah, I like this one because it emphasizes why you should sort. This is a really good sorting problem, actually. This is like a more classic sorting problem. Okay, I feel good about this problem. Interval, interval. This was the islands problem. So array and graph are covered. Islands is covered by graph as well. Yeah, see, even though it's matrix, it's like treating a matrix as a graph, which is actually very, very common. What about the rotated matrix problem? Word search treats the matrix as a graph. Spiral matrix treats the matrix as a graph. Rotate image maybe doesn't. Minesweeper maybe doesn't. So here's rotated image. So do I use, yeah, I don't see any BFS, DFS here. What about in the Minesweeper? Yeah, so even Minesweeper is treating it as a graph. Here it's like a pure rotation. So rotate image is like a non-graph. I'm going to make a note of this. So this is, it's still over 75%. So we'll say moderately uncommon. We'll just say uncommon instead of rare. So this is like 4 kata. Yep. Sorting intervals arrays. And then number of islands is really just for matrix, and then also there's graph there. Matrix, array, and then this should be solved with BFS. Kata, K-A-T-A. Like there's something here. Let me show you this. This is not like originally my idea, even though for Leetcode it is. But there's something called Code Kata. You can check this out. It's kind of like Code Wars. Oh, this is not really what I remember. Oh, I thought there was something else. Oh, even Code Wars says challenge yourself on kata. I guess maybe that's what I was remembering. Yeah, this is what I remember. So the idea of like practicing problems over and over and over to learn them, I actually got it from Code Wars a long time ago. So they basically call their problems, they call them kata. Let me make a note of that. I'll give them credit for the idea. Okay. So we have all of these solved. Now what about top 11 patterns? I'm sad that I get 2 more patterns and I have to have 2 more kata. I'm sad about that. I wish I could find a more efficient way to do it. They're just really different things. Like topological sort, you're not going to have a matrix with topological sort. You're just not. And you're not going to have a matrix with linked lists. You'd have to have like a really contrived and strange problem to do stuff like that. So I guess that's appropriate then. That they remain different problem types. So now the top 11 patterns are all of these. We'll do top 14 patterns consolidated, and then top 14 patterns right. So this would be the top 11 patterns exploded. Exploded. Is there an A in exploded? Exploded. Okay, there's no A. I feel like we did this already, but sliding window, 2 pointers, fast and slow pointers, merge intervals, sort, DFS, BFS, 2 heaps we're skipping. So we're skipping 2 heaps. And we're skipping k-way merge because it's also basically heaps. So that would be top 12, not 11. Oh, no, this is also heap-based. So 3 of them are heap-based. All right, good. I was like really worried about my life there because I've been advising people that if you take the low value out of the top 14, there are 11, and I don't think I was super clear about what those were. Okay, so of 14 patterns, eliminate low value, where low value is DP, heaps, it's specifically heaps. DP heaps and bit magic and number theory. Okay, so specifically the 14 patterns includes 3 patterns that are heap related. There's the 2 heaps. Top K elements. And K-way merge. Why did Control F not work for that? Did I misspell something? Top K elements. Seems like I spelled it fine. Maybe I pasted it wrong. Okay, so there's the top K elements and the K-way merge. Okay, so the top 11 patterns exploded then are yeah, I don't actually need to list them out now. So we have intervals, sorting, linked list graph. Intervals, sorting, linked list graph. So the, right. Okay, the patterns in the top 11 that are not included the patterns in the top 11 that are not included in they're not included in the top 7 are two pointers, subsets, binary search, and arguably two pointers are included in the top 7 because the top 7 include like string and array manipulation, and you often have 2 pointers for those. I'm not sure. I think subsets is like the really interesting one that's really missing here. So like binary search falls broadly under sorting and searching. 2 pointers falls broadly under string and array manipulation. Okay, so let's not say that they're not included. Let's say that they are not explicitly included or something like that. Subsets is one. That is arguably not included. Let's see. So subsets is not a tag. So subarray sum equals k. Subarray sum is not included. Okay, well that is a pretty common problem, so we should take a look at that one. Okay. How do we get subsets then? Subsets. So they're recommending subsets with duplicates, string permutations by changing case. Let's look at both of these. Let's make it easy. I mean, if there's not a good reason to make it larger than an easy. A good reason would be that it can knock out multiple of these patterns. So the patterns that we're interested in, two-pointer subsets, binary search. Subarray sum equals k. That's not, yeah. It's not what I'm looking for. Is this subsets with duplicates? Given an integer array nums that may contain duplicates, return all possible subsets. Must not contain duplicates. Yep. So I think this is the one that they're talking about. And let's check this one. Given an integer array of unique elements, return all possible subsets. Yeah. So subsets with duplicates would be this one. It's called subsets 2. Let's go get the frequency on it. It's like very rarely asked. This is a very rarely asked problem. Actually, both of the subset problems are rarely asked. Let's see. I should make a note of that. Okay, 3 interesting patterns. Let's see. So what was the other subset problem? String permutations by changing case. Letter case permutations, is this one it? Bit manipulation? Ew. Built-in library function is accepted? What? Sometimes Python is a cheat code. I want to make another article which is like 3 or 5 ways Python is a DSNA cheat code. What are you working on? I am making kata, or lists of practice problems, basically. And these lists of problems, the point is not to use them for learning. The point is to drill them so that they become like a muscle memory. All right, so this is letter case permutation. And yeah, this is asked. Yeah, this is asked. This is asked like 20% of the time. So binary search and two pointers. These are really the two that I want to add. Yeah, I'm not actually seeing those problems. Cool. So we will pick this search and rotated array. Search and rotated sorted array. I wonder if there's a more popular one than this. So this is binary search. Yeah, so there's more. There's more frequent ones. Random pick with weight, maximum profit and job scheduling. Let's look at these two. Median of two sorted arrays. Oh, there's no solution. Dynamic programming plus binary search. I'm not interested in that. No, no DP. So let's look at this one. Why couldn't you just merge sort? So you get the total length, and you start on the left of both of them, let cur, let last. So if L1 is undefined, why would L1 be undefined? If you go too far to the right, yeah. So these lists are not the same length necessarily. So while the pointers on both of them is less than the middle index, then you're going to like increment one of them. Return total length mod 2. Yep, so is it even or odd? So if it's even, then you need to take the average. Yeah. Otherwise, it's the current one. Cool. So I don't know if there's really an algorithm here. This is just kind of like a pure math kind of thing. So this is not using binary search. So is the idea you can do faster than this if you use a binary search? Maybe. This is like O of n. I don't think, yeah, you're not going to get faster than this with a binary search. Cool. So median of two sorted arrays is not a good problem because if you if you implement a binary search, you're just going to be slower actually. So I guess I like this search and rotated sorted array. Oh well, it's another case of I only get one pattern for one problem, which is not my favorite, but okay. Search and rotated sorted array. Well, here's just the straight up binary search problem, but it's the the frequency is less. What about this random pick with weight? Prefix sums with linear search. So this is a more practical problem, so that's cool. Given a list of positive values, we are asked to randomly pick up a value based on a weight of each value. So random sampling. Yeah, and I think that's one that's pretty intuitive. Let's see, what is the other problem that I picked? Search in a rotated sorted array. Feels like a lot more like an abstract Leetcode problem. Zero indexed array of positive integers. I should take a break, right? I think I'm getting close to done. I think I need to understand this problem better, but it does feel like a good problem. Yeah, so what is random pick with weight? So I guess the idea here is just how to apply a weight to your random function. Is that the idea? Um, Prefix sums. New solution. Solution is new solution 1 to 3. I really am not understanding this. You are given a zero indexed array of positive integers w. Okay, so 1 is it says input solution, but I guess that's the w, where I describes the weight of the ith index. For example, if w is 1, 3, the probability of picking index 0 is 1 divided by 1 plus 3. I think that's like a really confusing way to communicate that. um, Probability of picking index 0 is 1 over 1 plus 3. And the probability of picking index 1 is 3. Those could all be considered correct. Yeah. Okay, okay, I got it. Sorry. New solution 1 and 3. I'm like looking at this input, seeing all these empty arrays is throwing me off. But if I just look at this, 1 and 3, hello, one has, it's like one has 3 times the chance as the other. So I would want to I would want to sum up all of the array, and that would be like the total parts in like cooking terminology. That would be like the total parts. And then this would be 1 divided by the total. This would be 3 divided by the total, and so forth. And then I could simply multiply the oh, okay, that's tricky. So they're all going to add up to some number. So I would just pick the highest probability. That would be the one that I pick. Yeah, I think I would just multiply them by their ratio and pick the highest probability. Let's see if that's right. So prefix sums is what they're calling it. Yeah, basically they're adding up all of those weights. And now pick an index is total sum multiplied by a random number. I don't know about that. Total sum multiplied by a random number. Okay, that's a different approach than what I was thinking of. Run a linear search to find the target zone. Okay, yeah, they're doing something different. Okay, so they're taking the whole thing and finding a random, like consider a scale of 0 to 100 and just randomly picking in that, but that scale doesn't map 1-to-1 onto the array. A single slot in the array could be like 1, 2, 5, or 10 slots on the scale of 1 to 100. So that's how they're doing the weighting. Is they're using these, they're calling them zones. Was this considered like a medium? Yeah. All right, so let me just go ahead and solve this one. I think I want to recommend it, but I just kind of like have a little trouble recommending a problem that I don't understand myself. So I want to go ahead and solve this one. Okay, so let's go ahead and solve this one. I don't think I actually need to do anything in the solution prototype. Let me see. One, two, three, four, five. 1, 2, 3, 4, 5. Okay, so we need to pick once for every for every W. 1, 2, 3, 4, 5. Yeah, okay, so let me do something. I'll call it result equals null, and then return result. And then what would I call this? Like config equals W0. I think I can do pop. Let's say you pop off the stack, but I want the first one, so I'm going to call it shift. Let me just console.log config and W and make sure that I'm shifting correctly. So W should have, let me do it with and without this. So W should have a bunch of empty arrays, but also, yeah. Oh, it's only got one. Pick index is not a function. Sure it is. What? I didn't do anything. Solution.prototype.pickIndex. Goofy. Okay. Let's see. So I'm not calling pick index. It's going to call pick index. I'm just like, setting the weights basically. Prefix sums. Prefix sums is the thing that's weird. Is this Node.js or React? This is Node.js basically. It's kind of written old school. Yeah, I guess I need to use the this keyword. Okay, so it's not sending it to me as it seems in the description. Oh, well, there's the W, your input. So let me console.log. Let me do this. W is just a 1. So your input here, the input syntax is really weird. All right, let's put a pin in that and just see, okay, we're getting W like this. So if I'm getting W like this, that's a really not helpful test case. I want something that has more W than that. Wow, this problem is super rough. I'm like, I've read the solution, I understand the solution, and it's literally like the way that the input is passed is super goofy. For weight and W, prefix sum plus equals weight. This is going to be prefix sum plus equals weight. And then they append it into prefix sums. So it's the term prefix sum that is throwing me off. It would be like accumulated sum. Yeah, I think that's the better term. So we'll call this this dot accumulated sum for, we'll just call it accumulated sum. It's like accumulated sum at this index. And what I want to do is, for all the W's I have, for weight of W, then I want to, let's also have, an accumulator that starts at 0. So let's accumulator plus equals weight. So we're accumulating weight so that when that weighted random hits, it's going to keep going until it hits one that that beats it, and then we'll backtrack one index. Is that right? Something like that. Either until it beats it, or it beats it, and then we backtrack one index. I think it's something like that. Okay. And so now you can see that like the accumulated sum at that index, we're going to roll against that. So we can call it target equals math.random times this dot accumulated sum dot length. No, we would want the like the final, this dot final, or like last accumulated sum is accumulated. And that's going to have a value that's equal to the last index. So you'll never go over it. Like in the worst case, you'll pick that one. All right, so last accumulated sum. How long did it take you to get so good? Like 8 years, I think. Let's make it accumulated sums. So in the worst case, we're going to pick the very far one. What about in the very first case? You'll need to have a target. You'll need to have a target that's very small. So I think we can just do, if your target is less, is it your target is less or your target is greater? I'm going to just cheat and look at the solution. So if your target is less than ACK, they're saying return I. Okay, they want the index. Let's do it this way then. Okay, so it's always going to be a fraction of the last accumulated sum. That's right. So I never have to worry about exceeding the last accumulated sum, because the maximum value of math.random is 1. All right, that makes me a lot less nervous. Target. Oh, I didn't define ACK. Okay. All right, so we got a answer, and it's like kind of slowish. Whatever, I guess it's good enough. Oh, we want to do it the binary search way. Right. Yeah, so this is not the binary search way. So I'll split it in two, basically. So my pick index is bigger now. I'm looking at how they did it in Python. So this is how they do it in Python. So we got the target. We're still good on the target. I think you would want to find the, not just target is less than this dot accumulated sums, but like the maximum such that. Anyway, we'll run this. I think this like answer is not correct actually. Even though since it's like probabilistic, they'll give you different solutions. I don't think this is like a real random sample. All right, so we're gonna do it this way. Let left equal 0, let right equal right? Why does it say high equals 0? I think we want right to equal the length of this dot accumulated sums dot length minus 1. Okay, so get rid of that. While left is less than right. Mid is low plus left plus right minus low over 2. And then I think we want like Do we want to floor it? I think we want to floor that. Yeah, let's floor it. So if target is greater than this accumulated sums.I. We use mid there. Right. So we're going to cut the thing in half, and if the target is greater than that half one, we need to move to the right. Otherwise, we need to move to the left. So if we move to the right, then low or left equals mid, right? Well, they're saying left equals mid plus 1. Right, because it would be greater than, not greater than, or equal to. Else, right equals mid. So here's my problem is I think this isn't really a fair random roll. I think like, let me think about this. If I pick a low number, or yeah, if I pick a high number, I can always go low. Oh no, I guess not. If the target is higher, yeah, if the target is higher than mid, okay, that's how we avoid the cheating. Yeah, if the target is higher than low, I was thinking like it'll just like you can just always pick 0. Like the solution will just always be 0. Okay, cool. So let's run this. Submit it. Uh-oh. What's wrong with my code here? Oh, because I said low when I should have said left. And why is the runtime slower? That's super weird. I guess it's just the test cases they have. Yeah, for a large set, binary search will be faster. For small test cases, it's slower. I think that's right. That's pretty surprising to me. I would have thought they would have had some big test cases. Okay, so I think we're going to wrap it up there for now. I feel good about this problem. So this is random pick with weight. Good deal. I mean, the question prompt is horrendous, but the problem itself is good. So, yeah, this is for binary search. And then 2 pointers, I still like 3-sum. Okay, so we'll add these 2. And and that gives us the 6 kata. Solved by 6 kata. So it's 2, 4, 6, 8. There's going to be 2, 4, 6, 8. How can you incorporate merge sort? Do you mean into that specific problem, or do you just mean into like your learning regimen? Let's see, into that specific problem. Yeah, you would not want to use merge sort in that specific problem. But I do like merge sort for this problem up here. Number 23, merge K sorted lists. You would not want to incorporate merge sort into that specific problem. So that problem was having you try to randomly find a target and like the given data was already sorted anyway. So there's no reason, and there's nothing to merge. So there's nothing to sort, there's nothing to merge. You have no reason to use merge sort in that case. All right, y'all, thanks for joining. That's going to be it for today. And I'll write this up. We got 2, 4, 6 kata, and then I will also have like an option. So this is for the consolidated 11, and then I'll break it out to hit all these 3 individually, as well as add subsets and a longer one. So that might be like 9 or 10 kata, but that's going to be like a long kata. And then this is the one that I'll figure out which one do I actually recommend you do before an interview. But the best 2 problems will be alien dictionary and merge K sorted lists. So thanks for tuning in.